Hi and a very good day. So in this chapter, we will discuss on reading spreadsheet and database data. So in previous chapters, we have been reading data exclusively from SAS dataset. But actually in the real world, data does not always come in SAS format. It often comes from Microsoft Excel workbooks, corporate database, or other external sources. So for this chapter, we will learn how SAS connects to these external data sources and allow SAS to read and process data from Excel and relational databases, specifically Oracle, as if it were a native SAS dataset. So for this particular chapter, we will have two sections, which is reading spreadsheet data and reading database data. All right, and we will start with this first section, which is reading spreadsheet data. And for reading spreadsheet data, this is the objective of our study. Okay, first you should be able to use the valid var name option to control special characters in column headings at the end of section 7.1. Okay, so this particular valid var name is important to make sure that your variable name, when you read the Excel files, they will follow SAS datasets variable names rules. Okay, so that's why we use valid var name. And then we will use SAS access engines to access Microsoft Excel workbooks via the libname statement. Okay, so for this particular example, we will use libname statement to access the Microsoft Excel workbooks. But depending on where you program your SAS, you will have different types of engines to call the Microsoft Excel's workbooks. And then after that, we will use contents procedure to check, especially the variable name. If the variable name follow the SAS SAS dataset format. Okay. After that, we will use print procedure to display the data from the worksheet. Okay. And lastly is create a SAS dataset using an Excel worksheets as the input. So that's the objective of this first chapter. Okay, so let's take a look at this business scenario based on this diagram. The sales manager requested a report about Orion Star sales employees from Australia. The input data is in Excel workbook. So based on this diagram, we actually have sales.xlsx, and we are required to use this particular Excel worksheet to have some sort of operation in SAS. As an example, if you want to display the data set using SAS. Okay, how do we do this operation? And our task here is to connect SAS to this access file and extract the required data, or this particular required data. So you have to extract the Excel, and then we need this to extract the required data based on Excel. Okay, all right. So let's take a look at this particular diagram. So when we use SAS Excel, it will allow SAS to treat an Excel worksheet as if were a SAS dataset. Okay, so based on the diagram, when you see this particular diagram in your slide, this is actually a SAS dataset. Okay, so means that for uh, for whatever procedure that we learned before this in our previous chapter, when you have this kind of data set, you can implement it based on the standard procedure that we learn, the standard syntax that we learn using the SAS datasets. Okay, it means that we can use prop print, prop content, and even the data set statement with an Excel worksheets using the same syntax that we already know based on our previous chapter. Okay, so let's examine first our sales.xlsx file. Okay, actually when you take a look at this this data set, okay, this particular data set is actually in your PG1 folder, okay, your PG1 folder, and try to take a look at this sales.xlsx. Okay, actually we already upload in the folder, so you can view the original data set. Okay, for me I just search the data. Okay, I just search the data. Okay, and then I open it. Okay, so I can view the, okay, I examine whether this particular files is the same as our slides. Okay, alright, so let's take a look. Okay, now we have okay, here we have employee ID. Okay, as we can see here, the variable name is have space, so this is not a standard SAS format. Okay, embedded space in column headings. Okay, besides employee ID, you have first name, last name that have spaces in column heading. Okay, and based on this, as we can see here, we have two worksheet. One is Australia. Below this, you can take a look at this. Okay, one Australia and another one is United States. Right, and this birth date and hire date is already formatted. Okay, already formatted as dates. So this is the original Excel file format, right? Okay, after you view the Excel files, so based on material already discussed, does SAS allow embedded blank and special character in variable names? So take 2 minutes to answer this one. If SAS allow embedded blanks and special character, okay, remember again what are the rules for naming your variables in SAS. The answer will be yes or no, okay, and the answer will be no. Since that SAS variable names can be one to the thing is this one lah, okay, must start with a letter or underscore. Okay, subsequent character can be letters, underscore, or numeral. Okay, it cannot be the blank space cannot be used for SAS data sets. Okay, so this is the general rules for naming the SAS variable. Okay, so what we do when we read this particular Excel file, Excel column heading will be replaced. Okay, the blank will be replaced by the underscore, and if there is special symbols or way, they have a way on, means that SAS Studio or SAS, they have a way on how to deal with this variable name. Okay, so for this particular example, we take a look at how they deal with the blank, right? So depending on where you use your SAS programming, you might need this, what we call as SAS name literal. Okay, you might need this SAS name literal. So in the SAS okay, in the SAS string, this particular string, so this is a string, the variable name, within the quotation marks follow immediately by the letter of n. Okay, it can be either uppercase or lowercase. So this particular letter n tells us to treat this quoted string as a variable name. Okay, as a variable name, not a character value. So without the n, this n, SAS would treat job title as a character constant. So for this particular step, the SAS name literal, when you want to call Excel file, this is important. But again, it's actually depends on the engines that you will use. Okay, on the engines that we will use, whether you need this SAS name literal or not. Okay, I will discuss it later in next slide. Okay, so what we can do is we can set the valid var name option to enforce SAS naming rules in SAS Studio and SAS Enterprise Guide. Okay, so means that for this particular option, valid var name equals to V7, okay, it will force the Excel variable name to follow this particular rules. Okay, the same as SAS dataset. All right. Okay, so here we have several examples, and this is actually there are three engines. Okay, so this particular the highlight one here, we called it as engines. Okay, engines, this one that access Microsoft Excel workbook. So depending on which engines that we use, the way on how you write the lib name statement will be different. Okay, so for SAS Enterprise, when you use the PC to write your SAS programming, you will use this statement. Okay, PC file path equals to, you give the location of your files. But since that we use SAS Studio, we will use this particular engine, XLSX engines, whereby I already show you some example before this. If you still remember, where we have to adjust the examples, since that we use SAS Studio and we need this particular engine, okay, compared to others. So that's what differentiate between using SAS programming in your in SAS Enterprise and SAS Studio. Okay, so this is the comparison. Okay, we have Excel engines, PC files engine, SLSX engines. Okay, but the thing that you need to understand is for this particular SLSX engine, is only support Excel 5tat.xlsx. Okay, and the options that you can use, the options that we can use, this is example of the option valid var name equals to v7, is very limited. Okay, very limited. And for PC files and Excel engine, you might need additional software. Right? Okay, so let's take a look at, let's go through this particular slide. Okay, so this particular slide explain different engines. Okay, so this is Excel engines. So how do we use lib name for Excel engine to read the Excel file? Is lib name, read ref, Excel, and the extension. Okay, the engine name is optional if an Excel extension is specified. So means that if you use this as your extension, you don't have to specify this particular engines. That's the means. The SAS must be located on Windows. The Excel engine is used when the bigness of SAS matches the bigness of Excel. The engine uses Microsoft Edge engines. It means that they need additional software to read the Excel file. Okay, and it can read both .xls and .slsx file formats. Okay, it allows numerous nickname and data set options. So that's the advantage of Excel engines. Okay, what about the PC files engines? For this particular PC file engine, it can be located on Windows, Linux, or Unix. Okay, the PC file engine is used with any bigness combination. Okay, the size, your file size. Okay, and this engine requires server when Linux or Unix SAS is used. So they need to use server equals to some sort of the way lah. Okay, and it can read both .xls and .sls file format, and it allows numerous name and dataset option. Okay, but the thing that I want to stress is XLS engines, because we use SAS Studio instead of others platform. So this XLS engines require SAS 9.4 M2 or later. SAS can be located on Windows, Linux, or Unix. This engine is used with any bigness combination, so means any files. But the thing is, the differentiate between SLS engines and with other engines is it only can read this file format. So that's the thing that you need to remember. And as we can see here, if you use SLSX engines, you don't need to write the path equals to some sort of white. Okay, we just use this to give the location of your files instead of path equals to. So that's the different way on writing this lib name statement and also the PC file statement. Okay, for the PC file you need the path equals and so on. Alright, so if you want more information about the lib name engines and PC file server, you can refer to the documentation or you can use the helps button and search about these particular topics. Right? Okay, so for today, let's take a look at how this particular lib name is used for in SAS Studio. Okay, so for this particular example, this is example for SAS Enterprise. Okay, but since that we have SAS Studio, so some things that you have to understand is uh, we need to modify a little bit this syntax. Okay, so we don't have to path, we just give the location. Okay, we give the engines that we use is XLSX, and since that this is your data, you right click, you get the properties. So make sure that the location is correctly mentioned here, sales.xlsx, and this is the location. You copy the location and you put it in here. Okay, and then you can run proc contents. Okay, data equals to Orion x dot underscore all underscore contents salah je betul, contents. Okay, run. Okay, lib name. Okay, alright, so some changes need to be for this particular example, you have to modify this syntax. So this is the option value var name, lib name, Orion X. So since that we will save this particular sales.slsx in this library. So this is the libref, the library reference, and we use proc contents towards all the data available in Orion X library. So that's why we use this particular syntax to referring to the data. Okay, and proc context is to check the metadata. We want to know the structure. Okay, and then we run. Okay, so when we run, the thing that I want you to take a look is the variable name. Okay, so the variable name. So now the variable name, when you use the valid var name option, they change it into SAS variable. Okay, the space will have underscore. Okay, this underscore, and since that based on the Excel file, they already have format. Okay, especially in hire date and birth date. So SAS recognize this. When they read this Excel, they recognize this format and in format, and this is the label. Okay, the label for they will maintain the original variable names to become labels. Okay, based on the proc contents. Okay, so this particular oran dots underscore all, okay, will list all worksheets in the library. Okay, so means that since that in the Excel we have Australia, and based on this we have we have two worksheet, okay, Australia and United States. Okay, that's why we use this to show all members in the library. Okay, right. So for this lib name clear, what we do is we release the libref after we are done. Okay, so this is important because while SARS has a libref assigned to an Excel workbook, the workbook actually cannot be opened in Excel. So we need to always clear the libref when we finish. Means that any operation in our Excel in our operation here must be put in here. Okay, so for the next example, as we can see here, okay, set SAS name literal. Since that we use the XLSX engines, we don't need this SAS name literal. Okay, this is only for Excel and PC files engines. So that's why for this, when we do the next example here for prop print data, we don't use this prop print way syntax. Okay, because data equals to orient.x with the literal name is only for Excel and PC file engines, and for the XLS engine, this is the way on how you can prop print the data. So now try this example. Okay, you have to make sure that your prop print is in the program here. Okay, prop print data equals to okay. Now the variable name we will use variable names such as this is SAS dataset. Okay, now let's take a look at the results when we run this particular code. Okay, so now you will have this view. Okay, the employee ID, you will have 6 observation. Sorry, 5 observation read from the data set Orion.Australia. Okay, and for this particular variable name changes because we use the options var name. Okay, option valid var name. So that's why they have this log in your log section, and the result will have 5 observation 1 2 3 4 5. Okay, so since that in SAS Studio we use the XLSS engine, this is the way on how we write it. Okay, so let's take a look at this short answer pool. Okay, you submit the statement below. Which step display the United States worksheets? Okay, and okay, so let's say that this is by using the Excel engines. We take a look at the engine first. So since that this is Excel engines, you need the literal name. Okay, the literal name, and that's why you have to have this one lah. Okay, and since that how Excel, okay, when we go back again to this particular engines comparison, okay, the comparison, okay, when you explore the library, For Excel and PC file engine, the name will have this dollar sign. This dollar sign. Okay, whereby for XLS engine, you don't have to worry about the dollar sign. So that's why for this particular answer, okay, the answer will be D. When you want to referring to the United States worksheet, so you have to make sure there is this dollar sign and the N here. Okay, to tell the SAS, this is the variable name. Okay, the variable name that you want to refer to. Okay, and we have this business scenario. Create a SAS dataset using Microsoft Excel workbook as input, and they want us to use the same as this step. Okay, and you have this Australia Excel files, and you use the data step and create a temporary subset data. Okay, we will take a look at this example later. All right. Okay, so that's about creating a SAS data set from an Excel sheet. Okay, so we will continue a little bit about the Oracle, but for the Oracle part, since that we mostly don't use Oracle to call the data set, I just explain to explain this as your awareness. Okay, how SAS read the data set from a databases. Okay. Okay, so for this second section, reading database data, we have two objectives, which is use a SAS access engine to access Oracle relational database and use an Oracle table as input and data step to create a SAS dataset. So these two objectives are focused and practical. The key takeaway is that the LibName framework, which we used previously in SAS library and Excel workbooks, also can be extended to relational databases with minimal change in approach. Okay, so this is a scenario based on this diagram. So you have this particular Oracle database. Okay, the Northeast sales manager requested a report that lists supervisor from New York and New Jersey. The input data is in an Oracle databases. So the thing is, you want to extract from the Oracle database, you want to extract that particular data, which we need as a programmer, you need to identify the relevant table, okay, filter for New York and New Jersey supervisor. See that they ask this report need to come from supervisor from New York and New Jersey, and then you have to produce the report. Okay, so basically this is how we write the LibName statement, okay, for relational database such as Oracle. Okay, so the libref, if this is example of libref, the engine name, okay, and this is the option. Okay, so this is example, only example. You can go take a look at the examples. Okay, and then based on this, when we take a look at this OA, okay, OA is the libref. Once the libref is assigned, SAS will treat the Oracle database exactly like a SAS library. Okay, so the Oracle database becomes a library, and each Oracle table become a SAS dataset. So means that they treat that all the databases, all the things that in the database as exactly such as library. You will have a list of dataset in there, but when you write this particular name, all the dataset will become a SAS dataset. So means after that, when you have this particular name, you can use any procedure and any syntax that we learned before this previously in using SAS data, the same as this Oracle data. So that's the thing, right? So this is example when we use a two-level name to reference any table in this Oracle database. Okay, so prop print data where state in ny and nj and run. Okay, so this is examples. Okay, so you can read the documentation further for this particular information relating to a specific relational database. Okay, so means that if you take a look at the database, they are not only Oracle, they have these databases also, such as Microsoft SQL Server, MySQL, ODBC, and so on. Okay, it's not only Oracle, but for this particular example, we show you the Oracle one. Okay, all right. I think that's all for today's session. We will continue our discussion in next video. Thank you for listening. Bye.